Hi. So here we have a pretty difficult question, I would say. You have to figure out the number of distinct pair of integers m and n. So m and n are integers which satisfy this inequality. Okay. So we'll keep this part aside for the time being. Let's just focus on this part. Now, since we have mods on both the sides, that means this is a positive number, this is also a positive number. So if a positive number is greater than the other positive number, then square of this number, that means mod of m plus n whole square, will also be greater than mod of 1 plus m into n whole square. And now since we are taking square, there is really no need to write mod, right? Square of any number is always positive. So what we effectively have is, because this is true, then we get 1 plus m into n whole square is less than m plus n whole square. Okay. Now let's try to simplify this. We'll take care of this part later. So here let's expand. We have 1 plus m into n whole square, which is mn whole square, plus twice of 1 into mn, twice of m into n. This is less than m square plus n square plus twice of m into n. So 2mn gets cancelled out. So what we have is, taking both these terms on the right side, we have 0 is less than m square plus n square minus m square n square minus 1. Okay. So switching the sides, what we have is m square plus n square minus m square into n square minus 1 is greater than 0. Now let's do one thing. Let's club both these terms and club these two terms. Okay. So we have m square minus m square into n square. So if we take m square common, we have 1 minus n square over here. And since we have 1 minus n square, from these two terms, let's take minus 1 common. So we'll have a minus n square and a plus 1 here. So plus 1 minus n square. This is greater than 0. So again, taking 1 minus n square common, we have m square minus 1 from here. This is greater than 0. And this can be rewritten as m square minus 1 is as it is. But if I multiply minus 1 on both the sides, this will become n square minus 1. And since I'm multiplying minus 1, the sign will change, and 0 into minus 1 is 0. So what we effectively get is that m square minus 1 into n square minus 1 should be less than 0. So from this part, we get this thing. Okay. So now I'll erase the whole thing and just write down this. So what we have is that m square minus 1 into n square minus 1 is less than 0. So now we'll have to make cases for this. Product of two numbers is less than 0. So one is, product of two numbers is negative. This is possible when one is positive, the other is negative, or the first one is negative and the other is positive. So there are two cases. One is m square minus 1 is greater than 0 and n square minus 1 is less than 0. This is the first case. Or you have second case, case 2 is when m square minus 1 is less than 0 and n square minus 1 is greater than 0. These are the two cases. Now, how is it possible for n square minus 1 to be less than 0? Is it possible? N square is always positive. This number is always greater than or equal to 0. So the only way this whole expression is less than 0 is when n is equal to 0. When n square is 0, that is when n is 0. So if n is 0, this becomes minus 1 and then this has to be positive, right? So m square should be greater than 1 and n is 0. So now if n is 0, m square is greater than 1. Now let us look at this inequality. Mod of m plus n should be less than 5. So what are the values that m can take such that m square is greater than 1? So m can be either, it cannot be 1, right? It can be either 2. So 2 square is greater than 1 and 2 plus n is 0 here, right? So m plus 0, mod of m plus 0 should be less than 5. Let's do that. We know m square should be greater than 1. And now looking at this inequality here, so we have mod of m plus 0 should be less than 5. That means mod of m should be less than 5. That means m should be less than 5 but greater than minus 5. But we also know that m square should be greater than 1. So if you look at both these inequalities, the value that m can take is either plus 2 or minus 2. Plus 3 or minus 3, plus 4 or minus 4. These are the 6 values m can take, right? Such that m square is greater than, m has to be an integer first of all. M square is greater than 1 and m is between minus 5 and plus 5. So we have 6 values here for m and n. M is plus minus 2, n is 0. M is plus minus 3, n is 0. M is plus minus 4, n is 0. So we have a total of 6 possible values for m and n from here. Okay. Similarly, if you look at this part here, m square minus 1 has to be negative. Since m has to be an integer, this is only possible when m is 0. Now, m is 0 is what we get. And from here we get n square should be greater than 1. Now substituting m equals to 0 over here, we get mod of 0 plus n should be less than 5. That gives us that mod of n should be less than 5. That gives us n should be less than 5 but greater than minus 5. So m should be between minus 5 and 5 and also n should be between minus 5 and 5 and also n square should be greater than 1. So the values n can take is plus minus 2 or plus minus 3 or plus minus 4. Basically the same case with reverse of m and n. Here if n is 0, m has 6 values. Here because m is 0, n has 6 possible values. So from here the values of m and n are, if m is 0, n can be plus minus 2 or plus minus 3 or plus minus 4. So again from here we get 6 possible values of m and n. So the total possible values of m and n are 6 plus 6, 12. So there are 12 possible values of m and n. So pretty difficult question to figure this out in the first go. Probably a question which you may want to skip in the exam, and the answer is 12.